Hello everyone. This is a problem from mechanics and it involves application of work power energy or work energy theorem, and also it involves some concept from center of mass. So let's read through the problem once. The flexible bicycle type chain of length 5 pi square and mass per unit length rho is released from rest with angle theta equal to 0 degree in the smooth circular channel of radius r equal to 10 pi meters and falls through the hole in the supporting surface shown in the figure. If v is the velocity of chain in meter per second as the last link leaves the slot, then we have to find the value of v. We have to take pi square as 10. So I have the diagram here. Initially, this was the configuration of the chain, and the socket or the hole is in the form of a quarter of a circle, and you can verify that this chain will completely fill this quarter circle. Actually, the length of this quarter circle will be pi r by 2. This will be length of the quarter circle, and we can verify that this length will be equal to the length of the chain. So if you put the value of r, which is 10 pi, given 10 pi, then this comes out to be 5 pi square, which is exactly equal to the length of the chain. Now another thing is, if we have a wire in the form of a circular arc, then the formula for its center of mass YCM is r sine theta by theta, where theta is this half angle. So if we take y axis along this angle is theta, then YCM will lie somewhere here, and this YCM is given by r sine theta divided by theta. So this YCM we can calculate. Small r and theta in this case will be pi by 4. So sine 45 degree will be 1 by root 2 and multiplied by pi by 4. This 4 will go in the numerator. And if you solve this, you get 2 root 2 r upon pi. And from the given diagram, if we try to locate this YCM of the chain initially, then it will lie somewhere here. This will be YCM, and this will be equal to 2 root 2 r upon pi, and this will be 45 degree. Now once this chain completely slips off this circular hole, its orientation will be something like this, and the center of mass of the chain will be finally at this point. So the fall in the height of the center of mass will be this height plus this height. Once we know this total height, we can easily apply work energy theorem to get the velocity v. And since this chain is falling, all the parts of this chain along with the center of mass, all the parts will have a common velocity v. This v we have to find out. Now the length of the chain is 5 pi square, so this half length will be 5 pi square by 2, and this length will be YCM sine 45 degree or YCM by root 2. So let's apply work energy theorem between initial and final position. So work energy theorem, if we apply, we get the work done is only due to the work by gravity. So gravity will do positive work here. So mg into 5 pi square by 2 and plus YCM by root 2. So 1 by root 2 multiplied by YCM, we have calculated 2 root 2 r by pi, and the value of r is 10 pi. So multiplied by 10 pi, and this should be equal to the change in kinetic energy. So since the initial kinetic energy is 0, the final kinetic energy minus 0 will be half mv square, that is the final kinetic energy. So you can cancel v on both sides, and if we solve it a little bit, this root 2 will get cancelled, pi and pi will get cancelled. And also we have to take pi square as 10. So if you take pi square as 10, then you get g into 5 by 2 into 10 and plus 20 equal to b square by 2. So 2 will cancel out 10 5 times. So 5 into 5, this will be 25. 25 plus 20, it will be 45. And g, if you take g as 10, so 10 into 45 will be b square by 2, which will give us the value of b square as 900. And on taking roots, we will get b as 30 meter per second. So this will be the answer to this problem. So that is it. You can see it once, the complete solution. Thank you.